Hello, everyone, and welcome to the third session of .NET July, Microsoft Zero to Hero, a community-driven platform that is part of Microsoft Learn, and we are trying to connect learners and experts with each other, build up a community, guys. As always, be patient, respectful, and hear each other's opinions first. Maybe there is something to think about. The guy who happened to be a software engineer and for tonight. I hope you're having a great time wherever you are in this blue planet, whether it's morning, evening, watching the stream live, or recorded. As an enthusiast and C# programmer, I was most exposed to object-oriented programming. When I thought programming, I was interested to know how could I apply those techniques in an object-oriented language like C#. And glad tonight we have a great person at software developer, a core member of Reactive UI UI, which is a cross-platform composable model view framework for all .NET platforms. If you know about Reactive UI, don't worry, we'll share the links in the chat with you. Before getting there, I'd like to tell you something about our new portal, microsofthero.com. Further explore it, you could get to know how to contact us, how to reach out to us. Also, there's where you could see what are the upcoming sessions and workshops and everything about the community, and everything will be shared there. So for now, I'd like to, without further ado, I would like to invite Rodney on a stage to tell us more about how we could tame the mutable state in C#. Hi, Rodney. Welcome and thanks for being with us.
Hi, Shahab. Thank you for inviting me. Thank you for having me. It's a pleasure as always. Today, Mutable State, the hardest thing that we deal with as software engineers.
Yes.
So this is a talk that I've been giving for some years, and as with everything that I feel like in life, as you grow, the talk should grow. So this is kind of like the most evolved version of this talk that I've kind of ever done. It comes with about 10 years of RX experience at this point. So working with it every day in an actual production environment with actual live applications and users using them. So the talk is primarily from a MVVM mobile perspective because I'm a mobile developer. I want to let everyone know that these concepts apply to both Blazor and MVU, and that's actually part of the evolution of the talk that we'll get into here in a minute.
The MVVM pattern, any kind of application that you are making, it kind of applies there. I remember back in the days I was also using like some concepts in WPF applications. I think it could still be relevant.
Yeah, it's all relevant. I think MVVM is kind of the de facto framework we use in Microsoft applications. And now that Blazor is on the scene, we're using more MVU. So it's one of those things where these concepts apply everywhere, and that's kind of exactly what this new evolved talk is about, is how all of these concepts that I've learned over the last 10 years specifically of just MVVM and reactive programming and exploring the world and seeing what's out there and being a mobile developer.
Okay. So I'm really interested, like, to learn more about that. So the stage is yours. I'm gonna bring up your by the way, like the previous weeks, we also have a voucher as a giveaway. So if 50% voucher for all Microsoft exams, fundamental, or it goes to the best questions asked, which puts a little bit pressure on you, Rodney, using that question. So, fingers crossed.
Answering which question?
I don't know. I may come up with some questions myself just to get the voucher. Yeah. Okay. I'm good. Okay. Sharing. I'm sharing the right screen, or
can you see my slides?
Cool. Then, of course, any questions, I will just bring up the question at the moment and.
Perfect. So this talk is all about taming mutable state. Kind of functional programming in C#, and I probably should have put functional in quotes because there's a point later where I'll point out that like what I thought was functional isn't functional, and And F# is kind of what taught me that. So here we go. So who am I? Past Shahab's wonderful introduction. I'm Rodney Littles. Those are the places you can find me. There's a QR code that will take you to my blog, and you can see all of the random things that I do, and pay attention if any of this intrigues you. But I've been a .NET developer for, at this point, 22 years, I think. So I joined at the very beginning of the .NET 1 framework. It was an amazing time. On my journey, I've helped support an MVVM framework, and I've contributed to other MVVM frameworks that I use in tandem with reactive UI. I am an opinionated developer, as most of us are, and these are my opinions. I'm very much the type where if my opinions differ from yours, I actually want to talk to you about them so that I can understand a different perspective and see if there's a flaw in my thought process, because I don't think that I'm ever really done growing and learning, because the technology changes every week. So I feel like I have to adapt to fit the new technologies most of the days. Okay, so what you see and what you get. We're going to talk about some time I spent in the wilderness, I'll say, and paying attention to kind of what other frameworks are doing in the mobile space and what that taught me about MVVM. We're going to talk about what is mutable state, what is functional in object-oriented, and then we're going to get into some code samples where I'm going to try and bring everything together. So this is my disclaimer slide. I always put one in my talks because, I'm not going to sit here and tell you should listen to me. I'm not going to be the guy that comes up and tells you my way is right and your way is wrong. It's not how software works. Software has requirements. Requirements tell us how the software should be built, composed, abstracted, and everything underneath the software engineering umbrella, right? So I can't tell you that my way is better or worse. All I can tell you is what I think that I've learned through my time up to this point. And, you see this, if you're watching this a year from now, my entire thought process may have changed, because I may have learned something new that completely and totally changes the way I think about writing software. So there's been a lot of mistakes, and I've learned lessons and lost sleep and gotten my feelings hurt. I've gotten yelled at in meetings and told that the way I'm approaching things is incorrect. I've done it all, right? Like I've lived that software engineer life where I'm trying my best to be a good steward of the code, and by way of being a good steward of the code, giving the business what they need, not necessarily what they want, which is a fine balance. So model view update. While I did spend some time with model view update in Blazor, I will be honest, most of my model view update in Blazor kind of resembled MVVM, and I just kind of stuck a reactive UI shim on there, and MVU became MVVM, and I didn't have to change anything that I did. But I was looking at new mobile frameworks to determine how to migrate an application, if we were going to migrate it from Xamarin to Maui, or if we were going to migrate it to another framework. So I started playing with some of the other frameworks to get an understanding and to do that technical analysis. So the one that I spent the most time with and the one that I enjoyed the most was Flutter. And Flutter is built on the MVU, which is the model view update approach. I'm not going to say it enforces, but it drives home or kind of harps on the immutable state pattern, which is a pattern where if you have an object that has some state, instead of mutating the state in the object bucket, you return an entirely new object bucket. It's what I also learned is that Flutter is not functional at all. And I actually did want to learn a functional language. At that time, I was evaluating F#, which is also part of the later parts of this. And what I learned is that in MVU, you have to learn how to batch the right amount of change, which is when I kind of stumbled back upon a pattern that I've known for years called the state design pattern. And in Flutter, they use it with this technology called block. Now, I know we're in a Microsoft conference and we're talking about Microsoft, and here's this guy up here talking about Flutter. I'm talking about the things that I found that I liked, and I'm going to show you how I applied those things in the .NET space, so that I could get the same value out of what was in this other framework, in the frameworks that I know and love and that I use every day. So from that perspective, we get into model view, view model, right? So it's really all about responding to state changes, right? The view model should have knowledge of the domain. It shouldn't have any knowledge of the view. It should be responding to state changes from the user interface, from the external environment. This is where being a mobile developer is fun, right? Because what do you do when the internet comes out from under you and you hit a dead spot for cell phones, right? Your application has to be resilient enough to handle that, right? So that's state that could be passed into you from anywhere. And then the application, right? The UI responded and it updated the domain object and things have to happen, right? So all of that is that concept of mutable state. State mutates and things happen. I think one of my favorite examples of this is in a movie called Fifth Element, and the one of the gentlemen pushes a glass off the side of the table. It hits the ground, and then robots start doing things. It's kind of how MVVM works, right? Nothing happens, and then the user taps the screen, and then an explosion of things start to happen. And you have to maintain and understand what state is there, whether or not I'm in the correct, whether or not the application is in the correct state to be able to persist the data. If it doesn't have a local database and uses just API calls, all of that stuff is mutable state that you are responsible for. And the MVVM pattern becomes very unwieldy very, very quickly. But there are rules to it. Pardon me. There are rules to it. There's structure. There's responsibilities. There's ways to bridge the view and the domain from UI updates, right? Like you can listen to the environment state and handle it effectively. So there are patterns and rules that you can use, but I generally don't see people using them. I've come in to salvage a number of .NET applications that were built in MVVM in my life cycle, and every single one of them has had callback handlers in the wrong places, doing things at the wrong layers. And I know I sound like a purist at this point, but it becomes harder to maintain when you don't have a consistent way to do things, which is why we have patterns and practices in the first place. So just saying that you're using MVVM is kind of like how people say they do agile, right? Like they say they do agile, but they don't really practice agile. So what I find when it comes to MVVM is I find the view model becomes a dumping ground for everything. I've seen everything from JSON conversion to API calls that explicitly put header information from user interface input directly in the view model. I've seen view elements get updated in the view model because we just decide, oh, well, we can bring Xamarin Forms namespace into the view model because they're all in the same project, so it doesn't matter. And I've seen it, and it ends up becoming this kitchen sink of horrible state to manage in the most horrible way possible. And I don't fault the developers. I understand, right? Like when you're looking at requirements, it's hard to see what's coming down the road a week, a month, a year from now, right? So I don't fault people, but where we as developers have to be better is, when we see things shift, we have to shift with it. And we see things are getting overloaded. We've got to spend the time to go back and clean things up, which I work in a real world. So I know that never happens. And that's why adhering to the principles of MVVM can keep you out of those places. So now we get to the meat and potatoes. There is a white paper that was written by Mosley and Marks that talks about the majority of the complexity from all software comes from application state and managing that application state, knowing when the right time to show a widget is, knowing the right time to call the database, knowing whether or not the model that is bound to the screen is actually valid and will pass validation and will actually save to the database, right? Like all of those things are aspects of mutable state. And we as the developers are responsible for all of it. And the more the requirements grow, the more complex it becomes, right? We just talked about it. The requirements change, and I don't get to go back and massage the architecture to make sure that it accounts for this new thing. So instead of it looking like a house that was built all at one time, you can tell that that piece was added on 2 years later, right? Because we've learned new things. The C# language has evolved. So we immediately start using all the new features, but we don't go back and retrofit. Like all of these things happen. And I get it. We're all software engineers that live in the real world and deal with real software. But I'm here to tell you that there is a different way. I'll say better because I'm biased, and told you I have my own opinions. But I think there's a better way to managing complex state and state transitions and concerns in .NET applications. So again, it begs the question, like, what is mutable state, right? Like, so state is, like I said, the network comes out from under us while we're in the middle of trying to call the API to get data. The state, mutable state is the user entered something in on the screen, and we are filling out the model that is bound to the screen and running validation on it to see if we can pass it to the database to be saved. That's all mutable state. And hey, just showing whether or not the screen is busy, that's mutable state, right? Like, everything that can change in your application is considered mutable state. And I know that sounds really elementary, but it's funny how much you don't pay attention to until you get a bug report. It happens to me all the time. Oh, I didn't even think about that, right? Yeah, it happens. So we try and encapsulate that mutable state, right? And ensure that we, as the software engineers, have an iron fist over that state. We make sure that that state is pristine at all times, and we write all sorts of functions and methods and properties and classes, all to ensure that we have a handle on the state mutation. And then what happens? Another requirement comes in, and you look at your Rubes Goldberg machine, and there's no way to make the new requirement fit into that machine without tearing down a wall. Well, so that's the kind of the spider of mutations, right? Like, you get all of these different mutations, and this thing mutates, and this thing mutates, and this thing mutates, and you need to make sure that all of them are in the right state before you can actually go and do something else or perform an action for the user. And that's why writing software becomes extremely difficult. So here's an example, right? This is just a simple command. I'm sure everyone here has either written a command or something like it in their lifetime as a software engineer in .NET. But again, this points out the concept of mutable state and how easy it is to get state out of whack. So at the top of this, we have that if is busy, right? And if the view model is already busy, we assume that we can't do anything else, and we return, right? Because we don't want to execute. We want in-flight execution safety. We don't want to run a command that's already running. But now that begs the question of, do we have some external thing managing whether or not this command re-executes at the time that it's actually correct? Or are we going to expect the user to go re-execute that command? Don't know. Well, yeah. So then in the middle of doing all of this, right before we actually go call the database, we set this is busy to true. Well, because this is a mutable property and we can't lock down the mutability past the access of private, that means that everything in this view model can mutate its state, which now introduces inherent race conditions as to what the state of this object is at any given moment. That is the hard part about asynchronous programming and mutable state, is that you start to introduce all the race conditions just by changing the assignment of something from true to false. You have other methods that now need to go reevaluate, right? And it becomes very, very cumbersome. And then at the end of our execution method, right, we have this finally, just to make sure, just in case the method gets hung up or the exception doesn't properly catch, or I don't know what, the laws of .NET just immediately fail us, right? That finally block is going to save us and make sure that we set that thing to false when we're done. But what happens if another command in this same class is doing the same thing at the same time? Or worse, microseconds of difference, nanoseconds of difference, just enough so that when you evaluate the is busy at the top, that it returns true and your method doesn't execute. This is the problem, the overarching problem of mutable state. So actually, we need to go make sure that
we are seeing the example slides.
Yeah, it's funny because there was 2 slide decks, and I'm actually not sure which slide deck we're showing right now. So we're gonna we're gonna keep going through this, and we're gonna figure out how we get there. Yeah, you know.
But it's like mutable state implements search and like everything.
Oh no, yeah, I know what's up there. It's a question of whether or not that slide was supposed to be in this slide deck. So we're gonna keep going.
That's a surprise.
Yep. We're all going to be surprised today. See that's it, right? I mutated state. I created 2 copies of the state, and here we are in a debacle. This is just a search implementation, and yeah, I'm pretty sure this slide is actually not supposed to be in here. So we'll figure this out in a minute. The truth of this is that this is where reactive UI comes into play. We have this when any value at the top, right? So what this does is this tells us that anytime that the search text changes, that we're going to throttle the input. So the user is typing something on the screen. We're going to throttle the input, which means we're not going to process every single keystroke. We're going to wait for a quarter of a millisecond for you to stop typing, and then we'll process everything. We're going to do that on a background thread so that we're not blocking the UI thread, i.e. we're not stopping the user from inputting more information. Right? We're going to check to see whether or not the string is null or empty, and we're going to verify that the text that is coming in is distinct from the last text so that we're not constantly operating on every single keystroke again, or duplicate information. Let's say I have to hit back and then go forward. We want to make sure that I'm only processing the distinct changes, and then we go back to the main thread and invoke our search command. Right? That's the power of reactive programming, reactive UI as a tool to tame mutable state. Right? It gives you link over events. So I can basically run. This is just a stream of events that will run with link operators that you already know. They're just done on iObservable versus iEnumerable, and you get the ability to filter state. Go ahead. Oh, okay. You get a chance to invoke delegates, and everything is composable and neat and clean.
I have a question because you mentioned like in the back UI thread is operations that we are creating like when any value or throttle or things. Are they running on the UI thread, or is it like a background that we are?
That's a great question. So, and this actually came from a bug report. I learned this the hard way, that all state changes well, I hate to make the blanket statement, but I'm going to make it anyway. And someone later is going to tell me I'm wrong, and that's fine. Generally in .NET applications, the update comes on the thread that it is initiated from. So if it's initiated on the UI thread, it's going to come from the UI thread. So that means that when any value is going to get it on the UI thread. There is an operator in RX that gives you the ability to subscribe on a different thread, but it still will happen, I believe, on the thread that it comes from, but it can get marshaled immediately to a different thread. Does that answer your question?
Yeah. Thanks.
You're welcome. Great question. Because the second you get into thread marshaling, RX becomes very, very difficult. It's funny. I make the joke. Everyone says, Rodney, RX is hard. And I'm like, RX is actually real easy. The problem is that when you have a sledgehammer and you don't know how to check the wall for the pipe or the electrical first, that's when a sledgehammer becomes bad, right? So it's one of those things where when you don't know the problems that you can run into with thread marshaling and mutability, you start to run into all sorts of problems. I found a problem at work a couple of weeks ago where we thought we had encapsulated a state mutation in a transaction, and we didn't. And as a result, there were 2 different things trying to change it on 2 different threads, and the entire application was just completely out of whack. It happens. So observables are a tool to combat mutable state, right? It allows us to define state using a declarative approach. So we declare what the behavior of the object is in the constructor. We centralize that management of state because the majority of the brains or the majority of the code that you write is actually going to be in the constructor. And then we bind to whatever UI engine is available, right? Whether it's the WinForms UI engine, whether it's WPF, whether it's Maui, whether it's Blazor, we bind our state to the UI and we project our state downward. So the kind of begs the question of what is an observable? An observable is from the Gang of Four patterns. It's basically just the the observer pattern and implementation of it. System.reactive is a .NET specific implementation of reactive extensions, which are across pretty much every language you could want to write code in. Dart, Kotlin, PHP has it, for God's sakes. I mean, like every single language that you could probably want to write a modern application in supports reactive extensions. So it gives you the ability to do things asynchronously because they're asynchronous by default. You can schedule things on specific threads. You can emit values over time. You can use the await keyword, so the TPL syntax. You can use that with observables to get individual asynchronous returns. The one thing I will say is this, because I very much was the RX all the things guy when I first got my shiny sledgehammer. I'll say this at this point: observables are great, but they have their place. And where I think they have their place is streams of data. But if you're going to call an API and you're just calling an API to get some data, I would say use the TPL, use async and await, and be done with it. The observable pattern can be a lot to deal with for that scenario. But if you're dealing with something like a Twitter feed or just streams of data that are coming into you from multiple sources, IoT as an example, right? Like if you've got data just being fed to you en masse and you have to parse it, there's no better approach in the .NET framework than using observables. And I say that knowing that async enumerable exists, I still don't think it compares, in my opinion. So back to Mutable State, the state design pattern. So this is another Gang of Four pattern, and I know I didn't sign up for the Gang of Four talk. Yeah, I get it. But it's important because this gets back to the rules of view models, right? View models are representation of the state design pattern, right? The whole concept of a view model is it behaves differently based upon the state that it's in. That's what it comes down to, right? So you project state for the view to consume, right? When you go to the database, you get data, you bring it back into the view model properties get loaded up, bind to the UI engine, boom, it's on the screen. Fantastic. They respond to state from various sources. Again, the UI, the user is going to input stuff. The environment's going to input stuff. The application is going to be doing things in the background, right? Because we just said we're being fed tons of data. So we're using RX in the background to listen to that data coming in and determine when to display things on the user interface just from the application. And they also persist domain state, right? So what they should be doing is when the UI binds to a model and that model is valid, we should be then persisting that data down through the domain however we see fit. And domain is kind of an abstract term here, and I'm going to keep it abstract here because you could go from the domain-driven design concept of domain or the CQRS concept of domain or meet in the middle, and it's really all the same to me. You have a domain object that needs to get converted to a DTO that needs to get passed down the pipeline. Now, if you're creating a simple app and you don't need domain objects and you can get away with DTOs, fantastic. Again, I work in a very complex environment and come to find out that one of the other software teams put a feature into the production environment and they did not segregate their DTOs from a concept of what their domain cares about. So now that we are consuming and the way we have to consume it, we have to consume all of their DTO the way it exists because making the change is difficult. And as a result, the fun part, it's now bleeding into our application, their bad design decisions. So, if you're creating a simple to-do app or something simple that you're creating a prototype, I'm not going to sit here and tell you that you need a domain. Get away with DTOs. Once your application starts having real requirements, starts having real complexity and real problems that it's solving, I would recommend starting to to try and get a handle on that domain and understand what that domain state represents. So another design pattern that I've kind of happened into and started to use quite a bit more often is the mediator design pattern. And the mediator is also a kind of ambiguous. I actually look at it now in terms of CQRS. We talked about Flutter earlier. When I am in Rome, I try and do what Romans do. So if I'm in your country and the drink of your country is, Caparena, I think is how they pronounce it. It's a Brazilian drink. If that's I'll drink it because that's what it is, right? I'm trying to understand how the culture works in this environment. Yeah. So while I was in Flutter, everyone was pushing clean architecture, and I had already used Mediator in many other applications in my lifetime. And I realized that I don't like clean architecture at all. I think it's actually kind of toxic, because what it does is it basically just enforces potential conflicts, potential merge conflicts, as well as growth of specific classes based upon behaviors that they need to deal with. It just bloats things way too much. So even while I was in Flutter, I went back to the mediator pattern, and I had just implemented it in the mobile application that I work in, the Maui application that I work in. So what it comes down to is this. The mediator pattern is good at a couple of things, and we won't use it for the CQRS aspect of it, although I do use CQRS semantics. The truth of the matter is that we have, when the user clicks a button, we use the command pattern, right? We create a command in our view model that wires up to the command, to the button command, and we are commanding at that point. So let's just keep the commanding pattern going and send a command from the view model to the mediator, right? Why should we do any of that processing in the view model, right? We talked earlier about how view models become the dumping ground for all of this stuff that it shouldn't be the dumping ground for. So why don't we mitigate that by following a better approach to keeping things clean? Now, I'm very much the type of person that will tell you don't put architecture in until you need it. That said, there are certain things that I kind of, if the application is going to grow to a size that I think it is, i.e., by the time I start implementing real requirements, it's already too late, and then I have to take a step back and refactor everything. So mediator is really one of those patterns that I honestly just use in pretty much every application, because every application I use has UI that has to send commands. It has state that it has to query for, right? Like it has all of these things that are kind of good for the mediator pattern. Notifications that have to happen, right? Like, hey, I want to send a push notification. Well, I don't want to hold up the main processing and hold up the UI thread while I send that push notification. Well, the pub sub aspect of mediator then comes into play, and you can just publish it out, and you're good to go. So now you're not doing all of the excess stuff in a private method inside the view model. You're moving those things off into microtized single responsibility objects that you can test in isolation and verify the behaviors in isolation. So call me simple. Tell me I'm a horrible person because I put mediator and everything. That's fine. It's okay. Software seems to always work out the same way in general. So you remember earlier that I told you reactive programming is not functional programming. Boy, oh boy. While I was evaluating things, Fabulous was one of the things that I evaluated, because, why not? I'm doing an evaluation. I might as well evaluate F#. And F# is everything that like the syntax. Let me say it this way. The syntax is everything that I want as a function, or as a RX person, somebody that looks at the world as selects and reducers, right? Like I look at everything as filters, reducers. Instead of having to write a bunch of if statements, I just filter out all the noise and then only process the things that I care about. And I do that through select statements and mutations and filters and where clauses and all of those concepts. So I learned that reactive programming is not functional programming when I looked at F#, and I was like, oh, no, this is real functional programming. I had no idea. And I had been running around telling folks that I was a functional programmer. Oh, it was great. It was the best realization that I've had in the last 5 years. And what it comes down to is this. Functional means functions, right? You have things like discriminated unions. You have things like monads. For the record, I'm not going to define monad for you. You can Google it and be just as confused as me. I know what it is enough to get value out of it. I do not know enough of it to explain it past crayon. But you also have things like applicatives, which are basically combinatory functors over sets of data, right? So if you have think of a complex join situation where you join several object models together, right? An applicative would give you the ability to write a functor over each one of those things or all of them together. And then the immutable state pattern, right? Where we now in C# we have records, right? But a long time ago, I told you again just now or earlier that I've been doing this since the 1.0 version of the framework. We didn't always have records, right? We didn't always have the concept of immutable state. So the immutable state pattern is another thing that I learned in F# that is now a first-class citizen in C#, but didn't know and didn't care to know and didn't know that I didn't know. And I think the big one is the discriminated unions, which I'm coming back to, which is that either or, right? It's either this or that, but it can't be both. I know that there's a feature request up on C# for discriminated unions, and I know that they are working on it as best they can. But someone has solved, the .NET community is fantastic in terms of its open source offerings. Someone's actually already solved that, and I'll show you an example of it a little bit later. So all that comes down to, we have MVVM plus some concept of state plus some concept of immutability, and that's the sweet spot for us taming this mutable state with object-oriented and functional concepts. I'm very much the type of person where I say I don't think that either approach is perfect by itself, but I think that both of them together is the best trade-off that you're going to get. You can kind of get the best of both worlds, right? So MVVM is all about mutability, right? Like, this thing is enabled, we flip a bit, we flip a single property, and then the property is bound to another property on the UI, and one thing changes, and it's all about microtized mutable state. And remember earlier when we talked about MVU seeks to batch state updates because in MVU, state updates are a little bit more expensive. Probably not the right way to say that, but it's a little bit more intense. So functional really cares about being immutable, right? Like, I have state and I don't want to mutate state. I can return you a new representation of that state, but I'm not going to mutate the representation of state that I have. And then the state design pattern is about behavior changes on object state, right? So the behavior of this object is going to change depending upon what state it's in, right? I.e., that's the view of an application. If you are loading, right, it's in the loading state. The behavior of the screen is to show a spinner. If you are if you're searching, then you should get the searching animation, right? Like, that's how the state design pattern kind of like works, that stateful concept. So merging these things together into a application is kind of what I learned in the Flutter space and what I wanted to recreate in the .NET space. So again, we talked about functional patterns. Like, these are all things that C# has adopted over the years from functional languages, right? Records, strongly typed primitives. So your strongly typed domain objects that everybody was ranting about. The result pattern that all the C# guys were talking about, which already had a name called array-oriented programming, right? Like the with pattern on records that is new, right? That's the immutable data pattern. All these things C# has adopted from functional languages, and it's done it because C# knows the same thing that I do, that having the power of object-oriented concepts and functional approaches in a single language is the best way to tame mutable state. Full stop. So that said, we are going to jump in and start looking at some code. I'm going to pull some code up over here. Actually, I'm going to ask if there are any questions before I jump into the code.
There is no question at the moment in the chat, but I have a since, like, I mean, maybe it's irrelevant at the point in time. You could just postpone the answer to the end of the stream.
Yeah, sure.
So we had like 2 weeks ago a Blazor, and I was thinking, is like model view update pattern is like something that we could to the Blazor applications like easily with these reactive UI things, or does those things fit together?
Yes. So reactive UI does support Blazor. It is so that's kind of what I learned. Like MVU is distinctly different from MVVM, but we kind of bridge the gap because Blazor sends a state changed notification that we can listen to. So when state changes, we can go do stuff. So we just kind of played into the fact that we get that state change, and it's kind of like a hybrid MVU MVVM, i.e. Blazor is MVU, but you can wire it up to a view model, which is MVVM. So you kind of get the best of both worlds there. I have not, I'll go ahead and say it, I've written a couple of samples on it, but I've not written a full production application. So getting into the microtized state, like updating just a portion of the screen, I don't know how well that will work. But if you're using patterns like what I'm about to explain, I think you'll be able to manage it effectively.
Amazing. Like, I want to share you're the writer, right?
Yes, sir.
ID.
Yeah. So we're gonna jump directly into the fun. This is a Maui program that I've written. This is actually the source code that I've used for a couple of talks now because it's kind of a treatise to how I think .NET applications should be written these days. Still not perfect, but it kind of gets the points across. So the first thing that I'll point out over here in my Solution Explorer is that I only have a single assembly. And I know that that's really weird for a lot of .NET developers because they'll say, oh, you got to separate the data layer and put it in its own assembly. I don't think I care about those things anymore. I just have a single assembly. I've got a features folder, and all the stuff that I care about is underneath that folder. That's first and foremost, right? So that's just the overall how I've got this laid out, just so that you understand as I navigate through things. So digging directly in and just talking about like the immutable data concept, right? So this is going to be where I kind of jump around. I've got a couple of things to talk about, but I'm going to talk about them as it relates to things that we've already talked about. No, let's actually start with the state design. That's probably a better idea. So yeah, here is in Flutter. I told you that they have this concept called block, which is their understanding of a state machine, more or less. It has states and events, and it projects new state, right? And allows you to respond to state changes. So I wrote a wrapper around one of my favorite .NET libraries called Stateless. Stateless provides me the concept of a state machine. Oh, you guys can't see my subcontext menus. Oh well. Stateless provides me the concept of the state machine. It gives me the ability to, as you'll see, I'm bridging that gap of mutable state here with reactive programming, and I'm changing the state of the machine to something that I can use in an observable format, right? So I've got the current state of any given machine at any given point. And that gives me the ability to, it's not much to this. That gives me the ability to create a individual state machine for each view model. So now I have a state machine specific to the view model that I'm caring about. You don't have to do it this way. It's just the way that I've chosen to do it. If the requirements were different and I needed to reuse them, then I would find a way to try and reuse it. But that's not the important part, right? The important part is that I have something that's specific to my view model and works. And this is where I kind of wire up my state machine. So I can wire up the state transitions in a declarative manner. I know what states are permitted to enter other states. I have the ability to understand what state I'm in and keep certain states from going into other states, right? The key to this is that now we talked about the state design pattern. Now my view model becomes a more direct tie into my view and my view state, right? So if I go to the same, here we go, navigating around code, and I'll apologize in advance. I use C# UI because I like it, and I'm kind of unapologetic about that. So if you're a XAML person, this may look a little weird to you, but this is all using C#, there's a community XML markup, XAML markup for this that you can use, and it's fantastic. And that's all I'm using, right? So I've got the ability, because my view has knowledge of my view model, right? Through this concept here. So it knows what the current state is, right? So depending upon the current state of my view model, I am now able to turn on or off entire subsections of my screen, right? So we talked earlier about how MVVM usually has like, I've got an is visible property, and I've got a thing that says is enabled in my view model, and it's a Boolean property. And this one Boolean property changes this other simple Boolean property. And I have like 30, 40 properties in my view model that all have to be in the correct state in order for my view to respond. No, just no. I have one state. I have the current state of the state machine. The state is either initial, it's busy, it's loaded, we're looking at the day schedule, or something failed. Those are the only states that my view model can project to the view. So now, based upon those states, my view figures itself out. It says, oh, I'm in initial, I'm going to show these elements on screen. Oh, I'm in busy, I'm going to show these elements on screen. And no longer do I have a 50 view model properties all trying to manage microtized understandings of state. That's a view concern. That's what I learned from Flutter. That is a view concern. The widgets care about that. The view cares about the state of the view model. So the view model should just project the state, the desired state, not individual pieces of state, but an overall forest look instead of trees, forest look at the state, so that the view can just mutate what it needs to mutate. Now, I'll go ahead and tell you that when you look at this code sample later, this is a very contrived example, and it's always hard with code samples to give enough of an example. But I did recently talk to somebody, and you can technically tie this in with Visual State Manager and all sorts of other things that are available in Maui. I don't know what the performance will be. So that's where I'll tell you, I don't know where you can go with that. So I haven't tested it out myself. But that is actually something that I'm going to be testing out soon, is how performant is this approach? How well does the UI really respond to just a wholesale state notification and whole sections of the UI just vanishing or appearing? That's the essence of what this is really doing. And if that works out the way I think it will, that means that I've got this awesome new pattern whereby my state machine can determine what states are permissible for my view model. My view model can be tested based upon those states, and my view will just update based upon those states. And everything is peachy keen and hunky dory, right? Like everything's great because I've reduced the amount of mutable state that my application cares about. Now, not only am I taking better control of it, I'm also reducing the amount that my application needs to care about in order to act and behave the way I expect. Yeah. So on that, from there, right, our UI can update, and it can update our view model. Let me see what example. Okay, I have this example. So I'll show this example because this will be good enough. So I talked about the mediator pattern, and specifically the oh my God, I hate it so much I forget its name. It's use cases, clean architecture. There we go. I don't care about any of that. Like, I don't want to see, I've got a view model at work that has over 60 dependencies injected, right? Like, as good stewards of the code, at some point, some developer should have looked at that while they're adding that 60th dependency and been like, hey, this is a lot. We should find a way to make this cleaner, right? So this is the way I've chosen to make it cleaner. I have, again, CQRS semantics of a mediator pattern, and I use the mediator pattern to, pardon me, I use the mediator pattern to get the data that I require. Here we go. So I call my CQRS bits to create myself a new schedule, and off I go, right? Like I use the mediator as the thing that takes all heavy processing off of the view model and puts it in an isolated place that it can be tested. The number one question that I get from some of my developers is, oh, well, Rodney, it's in a private method. We can't test it. Well, first, yes, you can. It just becomes way more difficult. And second, if it wasn't a private method in the view model and it was in its own single responsibility object, it would be 10 times easier to test. So let's do that, right? Like, let's set it up that way. So that's kind of what this shows. And yeah, I'm gonna show you this. This is the clean approach, and this is why I don't like it, right? The clean approach, every single new requirement, every single query that I have to add, every command that I have to wire up would have to then be injected into this view model. And I'm going to get right back to where I was, where I have 50 dependencies in a view model. Don't like it. Can't stand it. Don't want anything to do with it. I'd much rather have this mediator that I inject. Yeah, there we go. I can click buttons. Maybe I can't. I got this mediator that I can inject, and it will tell me, or it'll do all of the heavy lifting for me, and all I have to do is provide it a command or a query, right? That makes everything so much easier, right? Case in point, right? So again, we talked about that is busy and setting that value to true and that mutation, right? Well, here I'm firing a state transition. Now, yes, there's another method that could be firing a state transition at the same time, but that will immediately change the state, and there's some guards in the state machine that will keep that from happening, right? I.e., if I'm already in the loaded state and I fire loaded again and I haven't wired it up, the state machine will throw an exception. Full stop. It'll throw an exception and it'll say, hey, you don't have a state transition wired up for this. We can't do this. Come back later. That's way better than a race condition, right? Now, granted, you'll have to find that condition at development time, but wouldn't you rather find a bug at development time than when it's out in the field? So this approach gives you a better tool to manage the state of your view model. Again, I'm going to get data off of the CQRS pattern, off of some query, and then I'm taking that result and putting it into things that the UI cares about, right? I'm adding that to the UI state. And yes, I still have to do a catch and fire the failure. It happens, right? Like, you can't get around everything, but this gives you a cleaner understanding of why I've started to use the CQRS pattern, because I've seen it where this would be a API contract that returns DTOs. And right here in this method, there's like 40 lines of boilerplate code that just doesn't belong there, right? Like, all of that gets delegated out to this handler representation. And now the handler's responsibility is to go get the data and return it. Makes life much, I'm not gonna say easier because there's trade-offs, but it's cleaner because you now have a segregation of the representation of your domain and the state that is, and what's responsible for what, right? Like, you are clearly defining responsibilities of things. And I find that when you're talking about taming mutable state, defining the responsibilities of things is very, very important. So that's kind of why I landed into that CQRS mediator approach. If you are using Maui, there's a particular library that I will plug called shiny.mediator. Alan Ritchie wrote it, and I think it's a fantastic approach to how to conceptualize mobile first mediator concerns, i.e. he's got an attribute you can add to a request handler that will ensure that it gets retried if the API fails, and it'll automatically set up a retry with backoff, right? Like, those are the types of things that it affords. And from my perspective, that's kind of why I like the mediator pattern, because you have things like pipeline behaviors that give you the ability to enhance the behavior of a query without explicitly modifying it, i.e. not violating the OCP principle from Solid. So it gives you those opportunities. So, and I know I'm coming up close to time. So what that kind of brings me into is the concept of the mutable state in the domain and my domain objects. I use a library called dynamic data, which gives me access to a source cache. What dynamic data does is it basically gives you all the functionality that you thought observable collection had when you first used it, i.e. it will provide both INCC, I notify collection changed events, and it will project I notify property changed events of elements inside the collection. So now this thing becomes basically a notification engine of anything that's inside of its domain. That becomes very, very helpful when I'm trying to project these things out into state for the UI, i.e. here on my UI, when I get a new medication schedule back from my immutable mediator call, right? It returns me a completely new object. I take that new object, wire it up, and start listening to it, and then immediately project all of that data out here to this schedule object, right? So I'm using RX and the power of the microtized iNotify property change to manage that state in a more encapsulated way, and then allowing those state changes to project to the UI. Then you, the user, can mutate the UI, and I get the response of those mutations, and then based upon the response of those mutations, I can fire off a mediator call to go and save my data down, right? So I'm now got this nice clean round trip where I bring back immutable data, and it's not really immutable because you can mutate it, right? But you mutate it to the point where the user, are satisfied, or the application logic is satisfied, and then it saves down. It can, because I have some that do auto saving, just by the by, and they save down, and then you get a new representation of that state, and you're adhering to a set of principles which helps you keep your architecture of your application together. It helps you keep your code base clean. It helps make things testable, manageable, and keeps all your responsibilities kind of in the same space. So that's kind of the 64,000-foot view of what this code base looks like. I mean, I could probably spend hours in here talking about it if we had questions, but that's kind of all I have for today, is showing you that if you lay out your application and you go in with the idea of taming mutable state, you as a software engineer are at war with mutable state, and you've got to win this war and provide the client with something that satisfies their requirements and will make them happy. That is your objective. And you have to get past this state monster in order to do it. And these are the tools that I have come to use over the past 10 years of MVVM programming in multiples of applications to combat that mutable state. That's all I got.
There are a couple of libraries you mentioned, Rodney. I think one was the stateless. If I'm not mistaken, it comes from.
Yeah, I can.
That
What I'll do, I'll pull those up. I'll pull those up and post them in now.
Do so. So, if any questions from the audience, we will be more than happy to answer them. There's also one library which I find out. It's about discriminated unions in C#.
Sure.
.NET uses source generators to implement that, which is very cool.
Which one?
Discriminated union net. I just dropped.
Oh, I see. Yeah, I see it. I see you just posted it. So let me post that one in there. That's stateless. And I did. Oh, there's one thing that I didn't show that I will point out. I did say that there's somebody that's already solved the monad problem. There's another library that I use let me be very careful with this. I used it in a couple of demos, and I was going to start using it in mobile applications, but at the time, just-in-time compilation, ahead-of-time compilation wasn't where it needed to be, and the .NET framework wasn't mature enough. There's a V5 beta that solves all of those concerns, so I'm looking at using it in MAUI applications again, and I'll drop this link in here in a second. This is language extensions. It literally gives you functional extensions in the C# language. And like I said, I did have an example of that in the code, but I didn't get to it because once you start to go down that level of functional, you're really kind of turning a corner. Once you start dealing with monads, everything becomes much more difficult.
I think what you're referring is like language extensions, right? This is the I shared it for those who I share it in the YouTube channel as well because you are just like platform visible. There's one request from audience. You've shown
share the GitHub. Yep. Oh yeah. Sorry, I was reading comments. Someone wants the source code to that repository. Yes. I'll give you both the source code to the I'll give you the source code to the repository. No problem. RX tracker. That's actually why I have this repository public specifically for people to look at and challenge me and learn from. So if you find anything on there that you have any questions about, like find me on the internet, ask me in public, tell me, Rodney, I looked at it and none of it makes sense. If it doesn't make sense to you and like it's just too complex for you, send me a private message. I'll spin up a screen share and I'll walk through it with you. I mean, like, I don't mind, because for me, like, getting to the individual developers and giving them the opportunity to see something new is way more enjoyable to me than most of the code that I write in my day job. I'd rather show you a different world that you never had the thought to see, because that's the only reason why I'm here, is because people showed me a different way to write code. I remember I always talk about this and he always yells at me, but Mike Stonis was on stage at the 2016 Xamarin Evolve talking about building better mobile applications with reactive extensions. And I saw that and I was like, I'm a mobile developer. I want to build better applications. And here I am in 2025 trying to share this information with you. So feel free to look it over, ask any questions you want. If you want to ask questions directly on the repository, however you need to, whatever feels comfortable for you, let's connect and talk about it, because I think that we as software engineers owe it to ourselves, with the advent of AI and everything that's going on, to do our best to create maintainable software for our longevity. Because what I've seen of the usage of AI is code bases are going to get progressively worse if we don't put things like taming mutable state as a first-class citizen in our applications. So
that's true. And that's what I also liked about the community, and also like myself, like sharing the passion that we have, like with passionate developers out there, just to reduce like the pain on one show.
Yeah. Yep.
Okay.
I mean, that's how you and I got introduced, right? Like we were talking about pain points, and the next thing you know, we realize we're dealing with the same problem.
Exactly. And I mean, I didn't start with .NET 1.1, which I think that's far from it. So yeah, guys, old, but it's fine.
It's okay.
Okay. And Rodney, for participating, giving the stage. I mean, let's share something else. Next week, we have started with Jimmy, and we will finish with Blake. But this time we want to test our applications, because it is really important from my perspective to have proper testing, no matter whether it's your domain or it's your model or UI layer. You need to have tests in place. So wrap up .NET July with unit testing, and we will and Steven Giesel, again another great developer in the community, will join us and enlighten us with how we could achieve these challenges in that environment. Great. Thanks, everyone. Wish you a great evening or morning. I know where you are. It's around noon, I guess.
Yep.
So last words, Rodney, for this session.
Thank you for inviting me. Thank you for having me. I always appreciate being given a platform to give my my opinions. And thank you, Stefan. Thanks
from everyone. Then
thank you.
Next week.